This conference will now be recorded.
So hello and welcome to you all. In the today's class, we are going to continue with the looping statements that are available in Java. Yesterday, we discussed about three looping structures that are available for while and do while. Today, we are going to start with the next looping structure that is available in Java, that is for each loop. So in this looping structure, uh, we use it basically to cycle through the collection of objects, and we will discuss it with the help of array. So the syntax of this is the general form or syntax of for each loop is first you will write the for keyword, and within the parenthesis we will write a type. It can be any type like float, int, double. It depends upon the type of collection through which you want to cycle. And then an iteration variable you will use over here. It can be any identifier. So for each of the collection element, this iterative variable will take one value at a time from this collection, and for that particular value, the body of the for each loop will be repeated. Again, I would like to remind you, if you want to repeat just one statement, then there is no need of parent braces over here. And if more than two or more than two statements are there, then you have to put the statements that you want to repeat within the pair of uh, braces, right? So let's discuss it with some example to make it more clear. So in this program, we have used one array. So although we haven't discussed array in Java till now, so there is a simple example of it because you already are aware of what array is actually, because you have studied C and C++ as well. So I will give you just a brief description of how we can create the array in Java, and in detail we will discuss in the coming classes. So this is first of all, the array is a collection of homogeneous data elements. So you can store the same type of elements in the array. So to declare the array, first you have to write the data type, the type of the elements that you want to store in the array. So here in this example, we want to store integer numbers in the array. So that's why we have written over here int. After that, this is the name of the array, nums, and we have used over here empty square brackets, and to the right of the equal to sign, we have used a list of elements in braces. So this basically, this syntax will create an array and initialize every element of the array with these values. So how many 10 elements are there? So this array size is 10. So basically in the square bracket we write the size of the array, but in case of initialization, array initialization, you can skip that. So here we are basically initializing the array. We are declaring it and initializing it. So when you declare the array and initialize it, the memory is automatically allocated. And the detail of this concept will cover in the coming video lectures. So the next is this sum is equal to 0. Through this program, basically we are finding the sum of the array elements. So we want to sum all these numbers from 1 to 10. So you should get the result 150. So main important point is how this for each loop works. So see here, as we discussed the syntax in the previous slide, first you will write for, then within the parenthesis a data type. So type is int, x is the iteration variable, and then colon, after that a collection. Here the collection is an array of type integer. So what will happen when for each loop is executed, this x variable takes one element at a time from the array that you have mentioned over here. So the first x will take value 1, then x will take value 2, then x will take value 3, and for each value of the x, the body of the for loop is repeated. So let's discuss it in more detail. So if when this will run, the x first time, the x will take value 1, the first element of the array, and then the body of the loop will be executed. So you will get this result, value is 1. And the next line, we'll add the value of x to sum. Initially the sum is 0, so the value of sum will change from 0 to 1. Then it will go to the beginning of the loop again, and with the second iteration, x will take the second value, that is 2. Again the body of the loop will run, so you will get the result, value is 2. And with this step, 2 will be added to the variable sum. The value of sum will change from 1 to 3, and again the loop will iterate, and x will take the third value, and so on. So it will take one value at a time. So when it has finished with all the values of this collection, this num array, then control will come out of the loop. So when the control will come out of the loop, in some variable you will have the sum of all the elements. So this will print the sum over here, and you will get 55, sorry, because the sum from 1 to 10 is 55. So this is what you are going to get. This is the next problem based on the same concept, but in this problem we are using break statement in the for each loop, and as we discussed in the class yesterday, that break statement is basically when it is executed, it terminates the loop. So how this will work? For that, we have again one array of type integer that we have created over here. This we also discussed in the previous slide. Then this for each loop, again we have used the iteration variable x. So x will take one value at a time from this array, and for each element it will be repeated. It will repeat the body of the loop, but this time we have added one more statement, that is the if statement, if x is equal to 5. So rest of the code is same. It will print the value of x, then the x will be added to the sum. So what is the purpose of this, that only we are going to discuss. So as we discussed in the previous slide, the x will take value 1 first, and then it will take value 2, then 3, and so on. So the purpose of this break is to terminate the loop. So when the x will become equal to 5, this loop will break. That means this program will add just the first 5 elements of the array. So 1, 2, 3, 4, and 5 will be added to x, and you will get the sum of first 5 numbers. So when break will be executed, the control will come out, and you will get the result, summation of first 5 elements is equal to 30, right? So whatever will be the sum, 15, I think so, the 15 will be the sum. So you will get the 15 result over here. The important point is that in case of for each loop, the variable that you use over here, it's a read-only variable, so you can't change its value. And another important point is when the break statement is executed, control come out of the loop, and rest of the iterations are just skipped. So this is the next problem on the same concept. So in this problem, basically we are performing a linear search. We want to find out whether there is an element in the array or not. So here this is the array. Again, the array name is sum nums, as we have used in the previous slides. And next, val is the value that you want to search. So we want to search whether this value 5 is there in the nums array or not, using the for each loop. So we have used one boolean variable found, and we have initialized it to false. So again, this for each loop x will take one value at a time from this array, and what we want to find is if the value of x is val, the variable value that you want to search for. If this condition value is to true, that means the element is there in the nums array, and we want to stop searching for it. So when this condition will evaluate to true, we'll set the found variable, boolean variable, to true, and the next break statement will terminate the loop. Control will come out, and when it will come out, this found is true. So if true, you will print, you will get this result, value found. And if the value is not there, then this condition will never evaluate to true. Let's say if I search for 15, so 15 is not there in this array, so this condition will never evaluate to true. In that case, the for each loop will terminate normally, and when the control will come out, the value of the found variable will be false. And in that case, because we haven't used else part in this if statement, so it will print nothing. So if you want to print that the value is not there in the list, then you can use the else part in the if statement, that if value is not there. So this is how it will work. Then is the nested for loop. So nested loops, we can nest one loop inside the other. This is true for all the four kinds of loops we have discussed, for while loop, or do while loop, or for each loop. So every kind of loop can be nested inside the other, or the two similar kinds of loops can also be nested. So in this case, we have nested a for loop inside another for loop. So if we look at this inner loop, so what it's doing, it is basically printing a dot. How many times this loop will print the dot? It depends upon the initial value and the final value. So in this loop, if we look at this, the initial value of j will be I, and its final value will be 9, because when the value of j will become 10, the loop will terminate. So final value is 9, initial value is I. The number of times this loop will repeat this printf statement, single printf statement, will be equal to 9 minus I plus 1. So when I is 0, so this loop will print this dot 10 times, 9 minus I plus 1. So 9 minus 0 plus 1 is 10. So this dot will be printed 10 times. When I is equal to 1, this dot will be printed 9 times, because in that case 9 minus 1 plus 1 is 9. So you will get 9 dots. So this inner for loop is being repeated by the outer for loop 10 times. First the value of I will be 0, and this entire body of the outer for loop will be repeated. So in the outer for loop we have inner loop. So when I is 0, this part will be repeated, and you will get 10 dots in the first line. Then why we are getting the dots in the same line? Because we have used print statement, and in case of print, it prints the output in the same line as we discussed in the previous lectures. When the control will come out of this inner loop, this print ln method will print new line character, and the line will break. So the next result will come to the next line. After that, the value of I will change to 1. From 0 to 1, 1 is less than 10 years. Then this entire part will be repeated again. So this time I is 1, so that means this loop will print 9 stars, and again this will print the new line character, and the control will jump to the, or the cursor will jump to the next line. So in this way you will get the this output as shown over here. So the next statement is about break statement. This we have already discussed in the previous two programs, but I'm going to leave it for you because this is the same code. So the next is labeled break. So this kind of a break is not available in C or C++. So label break, whenever we use the break statement within the nested loop, the control will come out of the loop with which you have the break statement. So if you want to break more than 2 loops, then this labeled break can be used. So we'll understand it in more detail through some more problems. So in this program, we have labeled some blocks. So you can create a block using a pair of braces. So one block is here. This is the starting brace. This is the ending brace. So whatever code is there, this will make one block. So this is one block, and we have named this block third. So how you can label a block? First you will write the label and then put the colon after that. So to label a particular block. So this label, for labeling a block, you have to follow all the rules of identifiers. That means the label name should start with an alphabet or underscore. It shouldn't contain any special character like space or percent sign. So you all know those rules. So this label should follow the identifier rules. So if it's a valid identifier, then only it can be used as a label. So we have created three blocks over here. This inner block we have labeled it 3, and there is one block. This second block is nesting the third block, so we have labeled it second, and there is one outermost block and we have labeled it first. So three labeled blocks are there: first, second, and third. So if you use just a break statement, if I don't write over here uh, this, then it will break the just the inner block. If you want to block break more than two or more than two blocks at a time, that this labeled break can be used. So how it will work, see here, only this line is important. What we have written here, if t is a boolean variable that we created over here, its value is true. So when this statement will be executed, it will break second. Break second means it will come out of the second block. So when it will come out, it's inside the third block. This if statement, this break statement is inside third block. But inside the third block, we are instructing the Java to break second. So it will come out of the second block. So the control will be transferred to the statement just after the third block, or following the second block. This is the statement following the second block. So with this break statement, control will directly come to this statement. Whatever statements are there in between this if and rest of the block, those statements will be skipped. So what we are going to get, let's discuss it step by step. So first is t is true, so control will come inside the first block. There is no statement, so it will come inside the second block. there is no statement in the second block in the beginning, so it will come inside the third block. So when it will come inside third block, there is a statement before the break. So you will get this message before the break. Then this if will be executed. So when if will be executed, it will come out of the second block. So that means this statement will be skipped. This statement will be skipped, and it will directly execute this statement, and you will get this message. This is after second block. So you are going to get two results when you will execute this program. You are going to get this before the break, then you are going to get this result. This is after second block. Oh, there is another statement. That statement is continue, that we can use with the within the loop. So what is its purpose? When the continue statement is executed in the loop, the control is transferred to iteration statement or increment decrement statement if it is within the for loop, and if the continue is within the while or do while, then the continue statement will transfer the control to the conditional statement of the loop. So this is the important point. I repeat, if the continue is within the for loop, then the control is transferred to the iteration statement or increment decrement statement, and statements after the continue within the for loop are skipped. So this statement will be skipped when the continue will execute. And in case of while and do while, the continue causes the control or transfer the control to the conditional expression, and rest of the statements are skipped. So what we will get in this case, let's discuss that. So I is initially 0, so 0 is less than 10 true, so you will get first result 0. Then 0 remainder 2 is 0, so it will continue. It will come here. So when it will come here, the value 5 will change to 1. So 1 is less than 10. It's true. So next you will get the result 1. Then 1 remainder 2 is 1 is equal to 0 false. So this will not execute, and you will get 1 space. So you will get the better result if you put something here. Let's suppose if I put over here n, or then you will get some value. So in that case, you will be able to differentiate that if this condition is false, then this is printing this thing, otherwise this is not printing this. So let me write it in the Eclipse, because there should be something over here, because null, we are printing null string, so you will not be able to realize that what is the difference between this. If we are not using anything, that it will not affect the outcome of the program. So I'm going to switch to the Eclipse. So I haven't started it yet. So let me start it first. Then we'll discuss how this will work. So I'm going to start Eclipse first. So let it start, and then we will discuss. Meanwhile, while it is starting, let's discuss the next problem. Then I will show you that on the Eclipse as well, the purpose of continue. Here we have used the labeled continue statement. So we are having nested for loops in this case. One loop is this I, and we have labeled the outer loop with the label outer. So this is outer loop, this one is the inner loop, and we have labeled the outer loop with the label outer. And inside the inner loop, we have used continue. So if you just use continue over here, if you don't write anything, then this continue will transfer the control to the iteration part of the loop in which it is contained in. So because this continue is inside the inner for loop, so if you just write continue, the control will go here. But because we are using continue with a label, so this continue will jump the control to this statement because the outer label is this, so control will go here to this expression. So this is the purpose of the labeled continue. So you can transfer the control to increment part of the outer loop as well. Otherwise the control will go to the increment part of the loop that is containing the continue statement. So let's discuss its output as well. So when this will continue, when the value of j is greater than I, right? So when you will run this program, the I will initialize to 0 and 0 less than 10 is true. So the control will come to the inner loop. So j will initialize to 0. J less than 10 is true. So j 0 greater than 0 is false. So this part will be skipped. And you will come to this statement and it will print I into j. So 0 into 0 is 0. So you will get 0 the result. After that, this is the end of the inner for loop. So control will come to this expression. The value of j will change to 1. 1 less than 10 is true and 1 greater than 10. So condition is true. So this will break the line and continue outer will shift the control over here. So the value of I will change to 1. And again this loop will repeat. So rest of the iterations I'm not going to discuss. If there is any doubt in this, either you can write your doubt in the chat box or you can leave your comments in the comment section. So let's now switch to the Eclipse. So here we are going to discuss the continue because in that program there was some issue. One statement was not there in the slide, so I'm going to show it here. So let me create a new class. The class name is, let's suppose this is continue one, first problem on the continue statement. So this is the interface. So let me remove this. So there is one variable, let's suppose integer type variable I. I'm going to use this loop for I is equal to 1, I less than, let's say 10, and I plus plus. Then in the body of the loop, I am going to write if I is greater than 5 and I is less than 8, in that case continue. Otherwise print the value. So here is the program with continue. So what we have written over here is if I is greater than 5, and I is less than 8, sorry, if I is greater than 5 and I is less than 8. If this is the condition, then it will continue. Let's check the output of this program. See here, we are not getting, so the result is 1, 2, 3, 4, 5. 6, 7 are missing because for 6 and 7, this condition will evaluate true. 6 greater than 5 is true, 6 less than 8 is true. So both the conditions are true. So in that case, continue will run, and when the continue is executed, control is transferred to this statement. So this statement will be skipped, and if this is skipped, you will not get that result. So in case of 6, because this condition will evaluate to true, so for value 6, this will not be executed, so 6 is not there. For 7, this will not be, this condition will evaluate to true, so the continue will shift the control to this statement, and you are not getting 7 as well. So this is the problem on the continue statement. So this is all about the labeled break or labeled continue statement.
This conference will now be recorded.
So this array will create a double type, this program in the first line will create a double type array num, and the elements will be initialized to the first element num0 will be initialized to 10.1, the second element num1 will be initialized to this, and so on. Now if you want to find out the sum of the array elements, you can use this loop, because the array index starts from 0. So we have written over here I is equal to 0, and the last value of the I can be 4 only. So this is 0, first, second, third, and fourth element. So we have written over here I is less than 5, then I plus plus. So what this statement will do, this will add the value of nums I to the result. The result is already initialized to 0. So this logic will find out some of the array elements, and when the control will come out of this loop, you are printing over here average is this. So average we have written over here in this, you will get that through this expression result by 5. So in result, we have sum of the elements, and 5 is the total number of elements. So this division will give you floating point, double result, floating, and you will get that. As we discussed earlier, I would like to remind you over here that double is of type, this result is of type double, and 5 is integer. So whenever the two operands are of different type, then the operand with the lower range is get converted into the higher range operand. So because integer is of lower range, double is of higher range, so integer will get converted into double. Then this division operation will be performed, and you will get the result over here. Then the next slide is how you can create a two-dimensional array. So in case of two-dimensional array, again you can write create the array in two steps. First you can declare the array using this keyword, this statement int to array name, and then double pair of square brackets, and put semicolon here. And the second step, allocate the memory, or you can do that in the same step as we discussed for the one-dimensional array. So here I have used only the one-step process. So this is the array type. This 2D is the name of the array, and after the square bracket we have left the two empty square brackets. So the first one is for the number of rows and the second one is for the number of columns. So when you allocate the memory using the new, again you have to write the data type, then the number of rows in the matrix and the number of columns. So here we are going to allocate memory for 4 by 5 array. So total number of elements will be 20. So this new statement will allocate 20 into 4, 80 bytes of memory for this array, and the reference of that block will be 2D. So basically in case of array, that 2D array in Java, these arrays are implemented in a different way. So in case of 2D array, these arrays are basically implemented as arrays of arrays. So 2D arrays are internally managed as a array of arrays. So what is the meaning of this arrays and array of arrays? We'll discuss that in this slide. So this is the one process of allocating the memory. This is the another process, and through this slide you will get to know what is the meaning of array of arrays. So here this is another way of creating a 2D array in Java. So the first step here is we are creating just an array, a one-dimensional array. So we are allocating, we have left the second bracket empty. So this will allocate memory or create the number of rows only. So a four element reference array will be created in this case. So let me show that here. This kind of array will be created. This is the array of size 4, this one, right? And every element over here is a reference type. So this is a reference type element. This is basically your 0 element, 2d0, and this is first element, this is second one, and this is the third one. This will be created. Then in the next line, we are allocating memory for the 5 elements using int 5. So what this will create? This will create an array of size 5. So I'm going to represent it here through the pen. So this is a 5 element array here, and the reference of this will be assigned to the first. So this is referring to the first array. So this is the case. Similarly, the second line will create an array. This line int new 5. This will create another array, and in this case, there are 5 elements again. This will allocate memory for the 5 elements, and the reference of this block will be assigned to the second element, and so on. So 2 more arrays will be created through this line. Through this line, another array will be created over here. So this is basically array of arrays. So this is one array, and every element of the array is of type reference, and every element will hold the address of another one-dimensional array. So this is the meaning of array of arrays. So this is an array, and this array is array of arrays. So the next is what is the advantage of allocating memory like this? Because there is another way that we discussed earlier. This is the one way through which we can create a two-dimensional array by just specifying the number of rows and number of columns. And then we discussed the another method of allocating the memory using this a little bit a longer process. right? That was a short process that we discussed earlier, but here we need to write the 5 lines for the allocation of the memory for the creation of the 2D array. The main advantage of this is that in case of Java, you can create an array whose row size can be different. That I have shown through this example. So in this example, we are creating a 2D array where every row has a different size. So let's say if I want to create this array where the first row has just one element, second row has 2 elements, third row has 3 elements, and fourth row has 4 elements only. So this triangular array we want to create. This is possible. This creation of this triangular matrix is possible in Java, and for the creation of such arrays where the every row can have a different size, and for that we use this process. So first we create an array with the only one subscript that we are creating over here. So it's a 4 row array, and for every row, as we discussed in the previous slide, for every element, for 2D0, 2D1, and 2D3 and 2D2, you have need to allocate the memory. So for the first row, we want to allocate just memory for the one element. So we have written over here int 1. So this will allocate one element array, and its reference will be assigned to the 2D0. So let me show you that again on the screen, how this will look like. This will look like this. This is a 1D array with size 4, and we are assigning the address or the reference because addresses are not used in Java. So this will assign reference of the first block to 2D0. Similarly, this is assigning the reference of the 2 element array in the 2D1, and this is assigning this to 2D2, and this one will assign to 2D3. So this is a one-dimensional array of references, and every reference holds the address of another one-dimensional array. So this thing can be created, a rectangular matrix can be created in Java using this notation, and some books used another word for such kind of array. These are called jagged arrays. So I'm going to so this is the name that is used for this kind of array. These are called jagged arrays, right? I'm going to write it here, jagged arrays. So this is the word that is used by some of the books for such kind of arrays. So here's another slide that is for the initialization of the 2D array. So just like the 1D array, if you are initializing a 2D array, then uh, you need not to allocate the memory explicitly. The Java will automatically allocate the memory for the array elements. So how you initialize that? Let's note that syntax. First you will write the data type over here, that is double in this case, then the name of the array m, then pair of square brackets, both are empty, with equal to sign. On the right hand side of the equal to sign, you will within a pair of square brackets, you will write the elements for the corresponding row. So this is the outer pair of square bracket, with every inner pair of square brackets we are initializing the particular row. So because 4 elements are there, to for 0 into 0, 1 into 0, and all that. So this will initialize the first row, this will initialize the second row, and these elements will initialize the third row, and so on. So this is row number 0, elements of row number 0, these are elements of row number 1, elements of row number 2, and elements of row number 3. And corresponding to that, this is the element 0 0 if we write it in two-dimensional form, and this is the element 3 3 2. Okay, this is column number 2, 0 1 2, and row number 3, so this element is 3 2. So then comes the alternate way of allocating the memory for the array. This is the one way we discussed earlier. First we write the data type when we discussed the one-dimensional array creation. Let me repeat that, then we will discuss the second method again. So this was the declaration that we discussed. In case of 1D, you will first write type, then array name, then pair of square brackets, and to allocate the memory we use this notation first, and the array name, then new keyword, array type, and square bracket memory. So this is used. So this is the important point that I want to remind you. First we write the array type, then array name, and then square bracket. But here in the slide that I am going to show you, this one, we are following some different syntax over here. So we are using type and then square bracket. Earlier we used square bracket with the array name over here. So earlier we used square bracket over here after the name of the array. So what is the difference between using this syntax and this syntax that we are going to discuss? If you use this syntax that we have written over here, this is also creating the array A1. This array name is A1 of size 3, and this statement is again creating array A2 of size 3. So either of these two syntax can be used, either this or this. So what is the difference? The difference comes when you want to declare multiple arrays. For example, in this statement, so here we have written data type, then a pair of square bracket. That means all these names, nums, num2 and num3, all are arrays of type integer. So with one pair of square brackets, you can create multiple arrays. This is the advantage. But if you use this notation that we discussed here, you have to write pair of square bracket with every array name. So here I have to write int a1 if I create want to create the three array a1, then empty square bracket and comma. Second array if I want to create, I will write a2, then second pair of square brackets, and so on, right? But in this case, if you use this notation, you can create multiple arrays with using by using just one pair of square bracket with the data type. Similarly, this syntax can be used for 2D arrays as well. This is the one way that we discussed earlier. First we write the data type, then array name, then pair of square bracket, then on the right hand side the new and the data type and the arrays, row size and row column size you have to mention. This is the second way through which you can allocate the memory for the arrays. So keep in mind, if you want to create multiple arrays with the same statement, then you can use this syntax that we have mentioned over here. If you want to create just a one array, then you can either use this syntax that is shown over here. Either you can use this or you can use this syntax. Right? So for the programming point of view, we'll discuss some problems on the Eclipse. And before that, I would like.
This conference will now be recorded.
So this is the doubt. I repeat, she wants to leave the first k element of the array, want to reverse the first k elements of the array and want to leave rest of the array as it is. So if this is my initial array with 6 elements, the elements are 23, 5, 7, 12, 8 and 9, then this should be the output. This should be the output. She wants to reverse the first three elements. So 3, 5, 23, right? I suppose the value of k is 3 and rest of the elements should be same. This is her doubt. So she wants to reverse first k element and rest of the elements should remain the same. How we can do that? So that's the problem and we are going to implement it here. So if you want to implement this problem, first of all we need one array. So let's say array name is a, right? We have another integer, let's say n and k and I. These are the integer variables. In variable n you can scan the array size. If I make it a general program, right, then I have to scan the array size as well. So for that I'm going to write over here import java.util.scanner to read the array size from the keyboard. So this is the statement. First we need to create the scanner class object. So this is what we discussed in the previous classes. You have to create the scanner class object. So here we are creating the scanner class object. We are allocating the memory to the object with the new keyword, right? And then if you want to read the value of n through keyboard, you can use this statement in dot next, right? Then you need to allocate the memory for the array. This is how we can allocate the memory. A is the array name. Then new can be used to allocate the memory. Int is the type of the array and we want to allocate memory for an element. So this is the array memory allocation statement here. I'm going to write over here memory allocation, right? So the next step should be read the value of k. First read the value of array elements. So I'm going to write over here system.out.println input. How many elements you want to read? That is n, and then put a plus over here numbers. So this will read the, this will display the message basically. I is equal to 0 and I is less than n, I plus plus. So this is the statement for reading the array elements. So for every element you have to write a of I. A is the array name, I is the index number. Then you have to put over here in dot next int. So this will read one element at a time from the keyboard, right? Then we need to read the value of k. So I'm going to paste it over here. So this will ask you the value of k, right? And when you input the k, you want to read that in variable k over here. So in dot next int will read the value of k, right? Now if you want to reverse the first k element, if the k is 3, that means the last element will be 0, right? Sorry, 2, 0, 1, 2. So if the k is 3, the last element position that you swap will be 2. For example, in this case, if k is 3, then this is 0, 1, 2. Third element is this, but this actual position is 2. So we want to reverse first k minus 1 numbers, right? First k minus 1 numbers. So I'm going to do that with this loop. For I is equal to 0 and I is less than k, right? And I plus plus, this is the case, right? And then I have to use in here, I'm going to use another variable, that is j. J is equal to k minus 1, let's say, because the last element that you want to swap is k minus 1, and here I want to write j minus minus. So j is the variable that I will create over here, right? So the value of I is 0 and that of j is k minus 1. The first element is in I, position of the first element, and position of the last element that you want to swap. Basically, we are going to swap the k minus element with the 0th element. So we will write over here t is equal to, t is the variable that we will create up, or we can create it here in t. T is equal to a of I is equal to a of j, sorry, j, and a of j is equal to d. So this will swap the 0th element and k minus 1 element. So I will explain it later how this will work. And then you want to print all the elements. So I'm going to paste it here. And instead of using this statement, I'm printing the kth element using AI. So this is my AI. I want to print it, and then I want to leave some space in between using this, and here I need a print. So let us check it. If there will be any problem, we will fix it later on. Let me reduce the size of this program, then I will enlarge it a little bit. Okay, so it's asking for the value of n first over here. So n is, let's go 6, right? Input 6 numbers. So these are my numbers. 23 first number, then second number is 5, then next number is 7, next number is 12, next number is 8, next number is 9. So I have inputted these 6 numbers. Enter. Now it's asking for the value of k, 3. I want to see here, we are getting, what we are getting is this is our result. It's actually the same. There is one mistake over here. It should be I is less than j, right? Yes. Let us test it again, because I copied this code and by mistake I forgot to change, make a change over here. So you can put I less than or equal to, or just I less than j, because this will work fine, I think so. Let me give the value of n again. This is 6. Input the numbers. Look at the numbers over here. First is 23, 5, 7, then 12, 8, 9. Value of k is 3. Look at this. So see, we should get this result 7, 5, 23, 12, 8, 9. So we are getting the same result over here. So this is how it will work. So let me explain a little bit to you. So this was our input, 23, 5, 7, 12, 8 and 9, and I put the value of k, 3 as the value of k. If the value of k is 3, that means this part we want to reverse, right? So the last element will be at place k minus 1. So k is 3. This is its position is 2 because the array index starts from 0. This is 0, 1, 2, 3, 4, 5. So first three elements we want to swap, reverse. So for reversing, what I am doing is I am swapping the first element with the k minus 1 element and so on. Then I will swap the second element with the k minus 2 element and so on, right? So for that I have initialized I to 0 and j to k minus 1, and with every iteration I am incrementing the value of I because I have started from the beginning and k from j from k minus 1th place, so I'm decrementing j. So this basically part is swapping the ith element with the jth element. So this is how we are reversing the first k element of the array, right? If there is any doubt, you can write